So this method is today we are doing flat discs, okay? They're round. So basically we're going to take, we're going to take a shape and we're going to rotate it around some axis, and then we're going to slice it up into solid discs, okay? So here's your, this would be probably your area like today, okay? Now, a drawing degree is not necessary to draw these, but they're not going to look like Abby's Foley's, just saying, okay? I can't draw, but you do have to visualize it because it will help. But basically, we're going to take this area, that was the area that maybe you found the area of last time, and you're going to rotate it. Actually, it doesn't stop there. It stops here, doesn't it? So this is the whole area, okay? And you're going to rotate it around the, looks like the x-axis, and you're going to create this 3D model, okay? Does that make sense? All right, right here, we probably took this and this, and we rotated it same way around the x-axis. We created this cone thing, and then to find the volume, we're going to find the sliced discs. So the discs over on this end are going to be bigger than the tiny little discs over there, but they're all going to be bounded by the same things. This thing and technically this thing, radius-wise. Okay, that's a cross section. Here's another rotation, same idea. We took this and we rotated it around. Do you remember those party things that you open up and they do that business? You know what I'm talking about? Like the Dobie bells and the turkeys that have the little thing. Oh, yeah. Okay, this is the same idea. That thing that you take and pull around is your axis of rotation right there. Okay, this turns into this when you rotate it. Okay, but there's going to be a hole in this, so this is a washer. Okay, anyway, just some examples. There's another cross section where you actually take your sections and divide them into certain shapes. Okay, so you're creating this thing by taking, here it is, by taking it and rotating it around, okay? All right, and what you want to do in this section is we're going to divide it up and find the volume of the figures, all right? Okay, let's match the graph. This is your simple graph with your rotated solid of revolution. Okay, now, I didn't tell you where you're going to rotate it, but which one could be this one? This one? Certainly. Let's just make it, oops, what happened? Okay, if you make it transparent, I don't know, I guess it's, yeah, it is. Okay, so where do you think you're rotating it? Down around the x-axis, right? Okay, x-axis, I'll just circle that, rotating. Okay, what about this one? Where's that going to go? Here or here? Okay, so you're rotating it again around the x-axis again. Okay, and so that leaves this one. I don't know why that was so right. And you're rotating it where this time? Upwise. Okay, so we can rotate x, y, we can rotate around any horizontal or vertical line. Okay, so you have to pay attention to what you're going to rotate. All right, the disc method is we took this graph and we're looking at finding these solids. Okay. Now, a disc is a tiny cylinder, okay? Here's the volume of a cylinder, pi r squared h, right? Here's your large cylinder from geometry. Here's your r, here's your h. Now, when you think about discs, you're thinking about very small, and that's what, I'm not sure what I listed this, but we're going to slice our solid, sorry, into vertical sections and approximate each section with the right cylinder. Tiny, skinny little disc. Okay? Essentially, this is our rectangular approximation method. We're just doing them, taking the 3-dimension and then revolving around the y-axis in this case. Okay, more slices we make, the more accurate. Calculus allows it to make an infinite number of slices. All right, let's take a look at one single slice here. All right, solid revolution is formed by revolving the enclosed area around an axis of revolution. This is my disk. What's my volume of my disk again? Pi r squared h. And we will delve into how we get all that from that. That's not a great picture. Okay, so let's take a specific, find the volume of the solid, revolving the region formed by f of x, which is right here. Okay, that's sine of x. All right, and we revolved it around the x-axis, and we are bound also by the x-axis. I think I have the link. Shows us how it does. How it works. Let's see if I can get it here. Maybe. Never mind. I'm not going to waste my time getting it there. Okay. So can you see that this turns into this after you revolve it? Okay. So it's nice if you can imagine it. It isn't necessary to draw it. Okay. If it helps you do it, it doesn't help, you can do without. Okay. So let's see. We have volume of disk. And I'm going to be real specific here because remember we are going to be moving on from disks. So I'm going to start like we have already moved on. So I'm going to be very specific. Is pi r squared h. All right. First thing I have to do is find r. All right. R starts at the axis of symmetry, or the axis of rotation, technically. Okay, so here it is, and it goes to the outside. So, whatever that might be. So this right here is my R. Okay, it always starts, and technically, even more specific, is going to be perpendicular to the axis of symmetry, the R, okay? So what is my R? This is the same R that we created to find that area length of a rectangle. So what is my R? Go ahead, Edo. What's my R, specifically? It's the length from this to this. Anywhere I might draw that little disc in there. The length from this to this. The length from this to this. The length.
They're not going to be equal?
Well, no, they're not going to be equal, but they're going to be bounded by the same and that, right? So it's the top is radical sine of x, and the bottom is, so that is my R. Okay, just like we did that when we were if we were finding the area, we'd go top to bottom, right? To find the length of the rectangle. So the length of the rectangle is the same here as our radius. Okay, so we're going to put that in here. R goes here. Don't forget to square R. All right, now, if this is a disk, right here, whatever one you have, this is a disk. Okay, that is one of those. We have an R. What's my width of my disk? Change in what? X. That's right. Okay. Now, the same rules apply for area as volume. If you hit the axis, it's in terms of that. So, even though you might not hit it right away, so this change in X goes here. These variables need to match. If they don't, this is really not negotiable. okay? If it hits the x-axis, it has to be this. If this is y, then you just have to switch up your r, okay? All right, now we're going to smash all those discs together, and we're going to do an integral. Go. Okay, we're going to leave that pi out because that's just ugly. So we're just going to leave it as a constant because that's what it is. All right, what's the radius squared? Sine of x. And what does change in x happen to be? dx. Very good. Okay, now we just need the upper and the lower bound. Okay, so we're doing x. Clearly, our first x is 0. What's our last x? How do we find that? Root sine of x equal to 0. Sine of x equals 0. X equals inverse sine of 0, which is 0, and pi. So pi becomes our upper bound. Okay? Because remember on sine, that's where we have 0. We also have 0 again over there. First time around. Okay? So that must be pi. You could also... All right. Any other questions that you all want to say out loud of into your seatmate, Ito? Because I hit the x-axis. With my radius, I have to draw my radius perpendicular to my axis of rotation. So this is my radius. When I draw my radius, I hit the x-axis. That tells me I have to be in terms of x. Because those are vertical lines, and they're in terms of x. We had to do that with the area, too. Okay? Because that's what it did on the Riemann sum. And started with the change of x, and then it kind of evolved into dx. Okay? Anybody else? All right, let's do it. Let's do this one by hand. Again, leave that pi out of it until we're done. What's the antiderivative of sine of x? Negative cosine of x, 0 to pi. I'm going to go ahead and switch the negative out here because I don't want to deal with that. All right, so cosine of pi minus cosine of 0. What's cosine of pi? What? Negative 1. Cosine of 0 is, all right, so we have negative pi times negative 2, which is 2 pi. So the volume of that eggy looking thing right there is 2 pi, 6.28, whatever, okay? So that integration is the hardest part, setting it up. And you are going to get confused. Okay, do I go change in x? Do I go change in y? So there are some things that you have to kind of make sure you're real methodical about doing. One is finding your r, the other one is finding what it's in terms of x or y. Yes? Yes. Yes. This tells you what you want your function in, because those have to match. Okay? Anybody else? Okay.
So, if it rotates around the y-axis, then it's changing y?
Yes, because you're going to be perpendicular. Yes. To that. Anybody else? All right, let's try the next one. Find the volume of the region in the first quadrant bounded by the axes and the parabola 1 minus x squared. Okay. What's the graph of 1 minus x squared look like? Upside down parabola, up 1. Okay, so there we go. A little lopsided, here we go. Okay, so that's at 1, just so we know. All right, first quadrant, so that would be here. All right, the solid, so you do this the same as if it was area. So you say, okay, here's my common, here's my area that we're rotating. Okay. And then we're going to rotate it about the y-axis. So it's going to go like this. And I feel like, what is it going to look like after it's created that volume, that shape? What's it going to look like? Like a dome. Yes, exactly. Okay? Yes.
How do you know it's the y-axis?
Because it's
Oh,
always
you said that. I'm
It's
sorry.
always-
I just
yeah.
saw that.
You don't ever have to worry about that. They will always tell you that.
And do you ever, like, what happens to the little, like, legs of the
Nothing, because you're just enclosing it within the first quadrant, so that's that yellow piece right there. Okay? All right, so I have to be perpendicular to my axis, so I gotta go this way with my R. Okay? So, volume, pi, R squared H of a disk. Okay? Pi. What's my R? Let's see. Over here on the right is the bigger number. Any of them will be on the, I got to go in terms of what? What? So I know this is going to be change in Y because I'm perpendicular. Okay, so my thing has to be a Y, my equation. Right now it's an X. Okay, so let's switch it up. So Y equals 1 minus x squared, y minus 1 equals negative x squared, negative y plus 1 equals x squared, x equals plus or minus. Okay. We have plus or minus. This is plus. Oops. And this is minus. Okay? Which one are we dealing with? Thank you. Okay, plus. Okay, so from the blue to here is negative y plus 1. No, sorry. I said that right, but I didn't do it right. Negative y plus 1. What's the other end for y? 0. Okay, so we're going to put that in here. And don't forget to square it. It's pi r squared. H, that's the biggest. A probably is 3 inches squared. Did I lose anybody on the radius? It's the same way we found the length of the area. For the area, we just took the bigger number, on a number line. The bigger number is over here. The smaller number is over here. So to find the distance, we're going to take big minus small. Okay, we're ready for integration then. Pi. That will remove that, and that changes to dy. Okay, now we're looking for upper and lower limits. And remember, these are in terms of y, how big and little y gets. Okay, of course, we know the smallest value of y is 0. Okay. We also know this, the largest value of y, because we already discussed that. What is it? 1. Okay. Be careful, this is the point where the ordered pair is the 1, so that's the top upper limits. Okay? It makes more sense when we're doing x's, so you have to kind of just think about it a little bit more. All right, go ahead and do this one. Leave the pi out of it till the end, even if you were doing it in your calculator, and then you get a nice, no, I wouldn't, because then you'll just have the x, the 1 negative, so. don't lose the pi. Did y'all get a half? Okay, good. All right, I just did it with my calculator. It's a dummy variable, and you have to put X in. Okay? All right, so find your area. Remember, you're rotating, so you need to be in terms of X or Y. Find your R, plug into pi r squared H. And then we're good. Any specific questions on this problem? All right, let's try another one. Okay, the graphing is there. Find the volume of the solid form by revolving the region bounded by y equals 2 minus x squared, which is the blue. Okay. And g of x equals 1, which is the red. About the line y equals 1, which is the same line. G of x equals 1. Okay, so we're revolving around the y equals 1. So now our area that we're talking about revolving is just this little piece right here, right? So if we wanted to revolve it, it end up looking like something like that egg-ish thing again, because it's going to revolve around the red line. All right? But for the radius, remember the radius starts in the middle at the axis of symmetry. So how am I going to draw that radius in? Is it going to be vertical or horizontal? Vertical, because it has to be, that's my radius. So what am I in terms of? X, because I would hit the x-axis if I kept going. Okay, so what's my radius? I'll give you a minute. Charlotte, what's my radius? I drew it in there for you. Or to the top is taller.
2 minus x squared minus 1.
Very good. The top is 2 minus x squared. Wherever you draw that vertical line, that would be the top of it. The bottom is 1. So we need to do that, and that would simplify to what? 1 minus x squared. Okay. Don't forget the square just because you already have the square. Don't forget it. Okay. And change in x is your height. All right, ready for a integration. All right, 1 minus x squared dx. Okay. Again, sometimes at this point you're like, oh gosh, we should have done y, so then you just back up. Okay, what are my upper and lower limits of the x? So I'm guessing it's here is my lowest x, and here is my highest x. Okay? Lower limits, upper. Okay? So how do you find those? What? I can't understand you. It looks like negative 1 to 1 on the graph, but can you rely on what it looks like? You should be able to put 2 minus x squared equal
To
1.
1.
Yes. Minus x squared equal negative 1, x squared equals 1. Is Debbie right? Of course she is. Negative 1 to 1. All right. If you were doing this by hand, what would you do first? Next. Square it out. Okay. You can go ahead and throw it in your calculator. I'm going to do it by hand, just as I can. It's an even function, right? what you got. 15, 16. Okay? All right. Even when you plug in the integral, leave the pi out of it. And then just don't forget to grab it. It'll just make it ugly. So when you do math 9 from -1 to 1, parentheses x, 1 minus x, oops, 1 minus x squared, close your parentheses and square the whole thing, x, get your 16/15, and then throw your pi out, okay? Don't even put your pi in there until the end. I mean, sometimes, if it's a free response, and you're going to multiply this together, you're going to use the 1.06666, it's okay to put the pi in there, especially if you have a habit of like, oh, I forgot my pi. Okay, then go ahead and throw it in there, because free response, that's a totally acceptable answer. The 3.351. Okay. So.
Silver, did you get a pie thrown in your face?
I did not. It didn't happen.
Why?
It's a long sad story. All right. So this is just summing up. We have the integral formula from A to B. The radius is r of x. Okay. If it's in terms of x, if it's in terms of y, it's r of y. Okay. Radii in the disk method are perpendicular to the axis of rotation. Have to be. There's no negotiation there. Remember, we're like, oh, we can do it like this if we want to split it up. But in volume, there's no negotiation. This is how it has to be. Disk method, radii perpendicular to the axis of rotation. Okay? So there is that you have to worry about differently than the area. The vertical radii, like vertical lines, are described using x, and horizontal lines described using y. All right. You want to try this one by yourself?
Yeah.
All right. I'm going to pause.
0 is your bounds.
Okay. So here we go. I'm going to draw my radius first. This is my y-axis. I need to be perpendicular. So I'm going to be in terms of y. Okay? All right. Now, my radius, I drew 1 in there. All the way to the right in terms of y is y to 3/2, right? Okay? And what's this side? 0. Why am I seeing 2 over there? What?
I thought,
I'm listening.
hold on, it's okay. Hold on, 1 second. I thought, like, vertical, I'm not talking about vertical.
We have to be perpendicular to the axis of rotation. All right. So my r is really y to the 3/2, right? Okay. Change in y. So what is y to the 3/2 squared? Y to the 3rd. Okay. And then our upper and lower bounds. 0 to 2. There's where your 2 comes in. Okay. If you're doing these by hand, pull your 4 out. You already got a 5 pulled out. Just makes it a lot easier to pull those constants out, ladies. Who got it? All right, good work. Okay, so there's still a little bit of a confusion. Let's try another one. I'm gonna stop taping, or should I keep taping? Taping, okay.
Probably be confused.
4 pi. All right. Sure. I was going to grab one that we have
So, and then, when we get the washer method and the different methods, then you have to like, oh, is this, this. So you really have to be comfortable with the method here. Don't try to be winging it. Because if you ever ask me for help, I'll start from the beginning. All right, so let's see. This is all going to be 6-1, all these three methods. 6-2 rather. Can you believe it? It's kind of crazy, isn't it? Okay. All right, so let's do find the volume of the solid bounded by, let's say we don't have any calculator here. Y equals x cubed, y equals 8, and x equals 0. Those are your boundaries. And rotated about the y-axis. Okay? Right. Yep, that's your call. Get it? Good. Few groups. Your pants are a little long here. I know Holly Dollar's the same thing. Cut them off. Because they're not gathered at the bottom. The axis has to be perpendicular to the rotated axis. So you went the wrong way. Yeah, that's wrong. Okay, this is not in terms of x, it's terms of y, so then you have to. Miss Kate? Okay, you're getting there. Sophia? overthought that one. Did you get it? Needs to be finished. Needs to be finished. Finish it. And it's cube root of 8, do it. And then this power.
Okay.
Because they wouldn't never stop there. Now, if it's a free response, you can totally stop there.
Wait, so can you do that? You know, like take the skin first?
Yeah.
And then just put it on.
Okay, I'm going to start it. Everybody ready? All right. We drew y equals x cubed. Everybody know how to draw that? Woot woot. Y x equals 0. Woot woot right here. And y equals 8 right here. Okay? Always label everything because then there's no question about, if you're not color coding, label because there's no question about what is that one again? And it just is helpful down the road. Okay, so I'm rotating up the y-axis, so my radius has to go perpendicular to it. I'm going to be in terms of y. No negotiation on that piece. All right, that's my radius of my disk. My radius is from the big over here, which is x cubed, but oops, I need it in y, so what does x equal? Cube root of y. Okay, so cube root is the blue, minus 0 is the green. And the distance of all these disks that you would put this way. Okay? So, volume of a DISC is pi r squared h. R is y to the sorry. Okay. Thank you. Change in y. All right. All right. Ready? Y to the 2/3. dy from 0 to at the top of y. Okay. And you get what? 96. 5. 96 over 5 times pi. Awesome. That's good. It's exciting. Yes, yes.